Hey, what's going on, guys? This is Jason from MicroSolderingSupply.com, and today I'm going to be going over a very common issue you see, which is iPhone 6 sudden no backlight. And a lot of times what happens, like this one did here, is where the customer comes in, they say, all of a sudden they woke up one day and they couldn't see anything on their phone screen, or all of a sudden it got hot and their phone died. And when you turn it on, you can see a faint like Apple logo, but for some reason you can't, it's very dark, you can barely see the picture, and so that's called no backlight. And so a lot of the times what happens on the iPhone 6 is for some reason those three backlight caps, like C1550 or C1551 or those ones will just randomly die. A lot of the times I think the idea is due to the heat from the CPU, as they're right next to the CPU, and when those die, it'll short the whole backlight circuit to ground and blow the diode. And so it's a pretty relatively common fix where you just replace the caps and you replace the diode, and you get like it comes out looking like this. It looks like you can see stuff now again. But what actually happens is, I can show you real quick that you don't actually have full backlight. So if I put these two together and I scroll these both up, you can see these are both at max brightness, right? But if I put them next to each other on the same white background, you can tell very clearly that the one on the left is nowhere near as bright as the one on the right. And you can actually see sometimes even a little bit of a flicker. I don't know if I can reduce it in this case, but sometimes you'll even see the backlight flickering a bit. And when you slide it in different directions, you see it only goes bright to a certain degree, while this one on the left will go all the way down and all the way back up again. Okay, and so, what does that look like? That looks like it could be a partial short, right? Well, it's actually, believe it or not, the coil. So what I'm going to do now is I'm going to show you exactly how that works and why it is the coil. So let's go ahead and power this off. Let's see. That's too bad. I had an iPhone 6 backlight coil by my desk, but I actually lost it, unfortunately, so we'll just have to take another random coil apart so you can see. Okay, so what you're seeing here is, if you look at this coil, you see that these two windings here on the end are all connected on the inside to a whole bunch of little wires. As you can see, if I put this flat, you can see the wires all there, where it literally coils around inside. And these wires are all coated so that they don't touch and don't short together. And the idea is, due to physics, all these loops of wire will create a resistance and impedance, and it'll slow down the current. And so what happens is, on the iPhone 6, you'll see like these will somehow short together on the inside. The coating will come off because of the fact that it's a short circuit and there's so much current all of a sudden flowing through that it'll burn through the coating and short some of the windings together, and result in a coil that is not of the right specs or has a partial short. And it's really hard to measure. You need like a really accurate milliometer to be able to measure that. So this is something that you can't really tell without replacing the coil, practically speaking. And so that's what we're going to do here. So I'm going to take this board out, and we're going to go ahead and pull the shield off. Turn on the air filter. Okay, so we got the shields removed now. So the first step here is, well, actually you can see that someone has already replaced one of the backlight caps and the diode before me. This was actually taken to another shop before I got it, and I guess they couldn't figure out why it only had partial backlight afterwards, so now it's here. But you can see the shields are removed, so what I'm going to have to do is I'm going to have to replace not only the coil, but a lot of the times the backlight driver too, because in the process of taking off the coil, the conformal coating around the backlight driver will heat up and cause the solder balls below it to move around, or it just ends up that being that the backlight driver ends up being damaged. So um, yeah, so I'm gonna have to replace both the coil and the driver in this case. So while I'm here, I'm gonna go ahead and just apply some Kapton tape over the CPU, because everything is right next to the CPU, and if I overheat the CPU, I end up with a dead phone, which is no good. So we're just adding Kapton tape. Okay, so now that the Kapton tape's added, I'm gonna go ahead and start removing all this conformal coating off of the backlight driver there. The problem is conformal coating will hold the backlight driver and the backlight coil in place, making it pretty difficult to remove. So I'm just using my tweezers to pick away at it. And yeah, this takes a while. I mean, you can add a little bit of heat sometimes, or use your hot tweezers, or your iron. It really depends on what you want to do. You don't need to have to remove everything, just like enough so that, for the most part, it doesn't hold the coil in place. It's kind of a bitch, but I don't know why Apple did this honestly, because it doesn't seem to make a difference besides just annoying us. But it's there. So yeah, that's the coil there. Um, just putting my favorite Georgia quarter over the CPU. This acts as a little bit of a heatsink to help protect the CPU. Also, like, why the fuck are these components so damn small? Like, seriously? It's a fucking quarter, and, like, that's the size of the CPU. Seriously? So a little bit of flux on top, and I'm just going to hit it with some hot air and try to pull the coil off. So now the coil's not really going to come off in one piece because it doesn't really work that way, unfortunately. You can try to get it off in one piece, but it's not really worth the effort. The coil really just likes to disintegrate on its own. So really, all you have to do is just make sure you don't pull the pads underneath. You can take it off as roughly as you want, and whether or not it comes off cleanly is really just luck or whatever. Of course, I'm doing it on video, so the chances of the coil coming off cleanly are pretty much none. Yeah, you can see it's already chipping away. You dumb motherfucker. Yep. Now there's the coil. That's what the coil looks inside. And so the trick here is actually you can use when you start chipping it away like this, you can see when the pads are starting to melt, and because you'll see the solder underneath turn shiny like that. And so now that's one side done. So now I just got to get the other side off. And so I'm going to use, now that I have the top pad exposed, well, you can actually see here, like those windings, you can see how they're kind of silver there. That actually might be where they shorted together. The coating on the wire makes it turn that color of like brownish copper, um, but like there's some silver on the right there, which kind of indicates to me that that actually might be where it's short, which is kind of cool. I've never actually seen that before, but that's the idea of how the coil fails, is that the windings internally short together. So I'm just going to pick away a little more of this conformal coating, and then what I'm going to do is afterwards I'm going to use, when I heat it up, I'm going to watch the top pad there and see when it turns silver and shiny. And when that turns shiny, I'm going to know that the lower pad has melted as well. And so that's going to be a good indication of when I can pull the whole thing off. Like I said, doesn't matter. Oh, there it goes. Doesn't matter if it disintegrates into a million pieces like that. And so now just take away all the crap that's gone. And so while I'm here, I'm gonna go ahead and do this cool little trick on the backlight driver in order to take it off. So you can actually take off the backlight driver without using any hot air, just your iron. So what you do here, it's a really cool, neat little trick. I gotta say, I stole it off of YouTube from I think like Oshbach or whatever. Um, and so what you do is you just scrape off the top black coating on the IC chip until you get to the exposed glass underneath. And then you just take a fat iron tip. I love to use this like fat ass wedge iron tip. I'll show you in a minute. And what you do, it's really cool. You take a blob of solder, stick it on your tip, and then just touch the top of the IC, and the heat will transfer through to the IC through to the balls, and just completely pop that chip off without any hot air and without damaging anything around it. Now, this will completely fuck the chip over, but um, you know, we're not going to be using that chip anyway, so it doesn't really matter. So only use this trick if it's a chip that you don't want to use again. You got to make sure to, just use your tweezers or whatever to try to get rid of any of the underfill or conformal coating that's around it. You don't have to remove it all. Just, try to get it as much away as you can so that it doesn't really hold down the chip and it makes it easier to remove. Now just stick some flux on and grab your iron. I'm going to show you my tip actually. Tip of my iron. Hint, hint, JK. No, yeah, so that's a T15 D2 tip. It's a 2 millimeter wedge tip. I love it for this job. You can use any, like, really you just need like a big ass tip. So what you do is just touch the top of the IC like that, have some solder on the blob of your tip, and bam, you just pop the IC off, just grab it with your tweezers, and just once it moves, just lift it right up with the iron, and it'll come off perfectly clean. And so now all you gotta do is just whip away any of the excess solder there. So just apply some flux, cut off a piece of wick, and just hit it with your iron, and it'll suck it all up. And just like that, you've removed the IC with no damage to any of the surrounding components. Alright, so now we want to start cleaning up the pads a bit so we can put the new IC on and the new coil. And so first things first, a little bit of flux. And then what you're going to do is just take your your iron tip, and then add some leaded solder in there and just start cleaning up the pads. And you don't have to get them like perfectly flat. I don't bother really wicking them because it's such a small IC. I generally only wick larger ICs. Like smaller ones like this, I can usually get away most of the time without wicking them in order to get it flat. And the problem with wicking them is, it just creates like I'm a competent wicker. I don't know if that's a word, but I don't wanna risk it when I can. And now you can also see there's still underfill left from under the chip, so that has to go too. And so what I'm going to do is just use my hot tweezer tips and just start picking that away gently. Got distracted by a customer, so here we are back at just picking away the underfill. So like I said, just use my hot tweezer tips. So I'm just putting some flux down and then adding a little bit of, a tiny bit of solder to my tips. And then just using that heat to scrape away the underfill. Now you got to be really careful here. The one thing you don't want to do is scrape the board. Or when you scrape the board, you expose the ground plane underneath, and you also risk pulling up all the pads. And when that happens, you're kind of screwed. Exposed ground plane, especially on underneath VGA chips, is literally like hell on earth in terms of repairing. So just be very gentle, go very slowly, and just uh, gradually pick away at the underfill. And when it gets really dirty and brownish and you can't see like this, just grab a Q-tip and make sure to just clean it up. There's really no point in not being able to see what you're doing. Now just repeat the steps over and over until you get it as clean as you can possibly get it. So that's starting to look pretty good there. It's still a little bit off to the sides, but below the IC chip is starting to look pretty good. You can see like there's no more, there's less underfill. I still have like some on the sides that I need to pick away, but there's like less underneath, so the chip's gonna go on and sit on correctly. So yeah, this process just takes time. It's kind of a bitch, but what can you do? Uh, yeah. So yeah, that shit underneath the coil also has to go because the coil has to sit flat on the board. So same concept, just hot tweezers and just gently scrape it away. Like I said earlier, do not scrape the solder mask off. And now we're just gonna go ahead and clean off everything. Make sure that all of our underfill, all of our crap is gone. So just a little bit of alcohol. And that looks pretty good. Just take off a little bit of whatever I missed. You can see here, I did expose a little bit of the trace there between the diode and the coil pad, but that's perfectly fine because that's that ground, and that's not going to be short anything out. So now just make sure that the coil and the diode measure out. Sorry, the diode measures out. So 0.2 in one direction, and then I've got open line in the other. So yeah, that's a good looking diode. Now I'll just check real quick for continuity because I know I exposed that trace there. Make sure it's not short to ground. And it looks good. Yeah, 0.32, so that looks pretty good. So now we can go ahead and get ready to install a new driver and a new coil. So after we get our coil, I'm going to probably start out with what I usually do is, well, first I got to tin the pads. Can't forget that. You want to tin them very lightly, like that's just enough. If you put too much solder on the coil pads, your coil is never going to sit flat, and that's going to be impossible. So very, very, very little solder. And so I'm going to start out with just kind of like tacking the driver down. What I'm going to do is actually use my hot air to just gently uh, like melt the pads on the coil so that the solder flows pretty evenly. And while that's happening, I'm going to have the driver in place, like you can see here. A1 is in the top right corner. You got to remember that. These don't be like Sonny, who puts his drivers on backwards. And yeah, so I'm going to take my hot air and just like gently flow those pads on the coil to make it all even. And then at the same time, it's not going to fully solder the backlight driver IC on, but it's going to, tack it into place for the most part. So yeah, that's my backlight coil there. It's a new one. Just put it off to the side. Now just come in with your hot air and gently warm it up. So just wait for those pads on the coil to start to turn shiny. Now, if you tin these with leaded solder, it'll melt pretty easily like that. You see, so the top, they both just float a little bit, so they're a little bit more even now. And now you can just add some flux and stick your coil down, and you can sort of flow them both into both the driver and the coil into place at once. In theory, always in theory. Now that I'm on camera, we'll see if that works. So I'm just kind of trying to hold the coil in place, kind of failing at it, as usual. Yeah, see, this is an epic fail. What the fuck am I doing? What the fuck, dude? Alright, that's better. Yeah, there you go. Now the coil jumped into place. That's good. So now we just have to wait for the, you can see the diode snapped into place. Now we just gotta wait for the backlight driver to snap into place. Eventually, sometime. It's very crooked. So what I usually do is I line it up relative to the diode. It should be, like pretty much parallel to with a diode. Now, since you're right next to the CPU, you've got to really watch how much time you're putting in here. Too much heat in that area is going to cook your CPU, and you're going to end up with, instead of no backlight, just like a dead phone. And as you can see, the backlight driver is really struggling here. It's really giving me a hard-ass time. So, yeah, this is already a lot of time, and you can see I'm pretty, like, not really satisfied that backlight driver is going in. So I'm just going to go and pop it off and figure out why that is. Most likely the reason is normally I didn't clean off all the underfill or everything underneath it. So I'm just going to take my hot tweezer tips and just flatten all those pads out and make sure all the underfill is gone. This happens. I mean, what can you do? It's life. I'm on camera. Shit doesn't work. But the part of being professional is we can fix our fuck-ups. I'm just turning the board around so I can get better angle at the other pads on the side there to clean them up. And yeah, the diode's out of place, but that doesn't matter because when I hot air it on, it'll snap back in. It's the glory of good flux. Amtech 559. Available on MicroSolderingSupply.com. With the plunger and the tip. You just gotta check the little box, guys. I know you guys always send me emails. Check the little box under the product page. On the product page, above the add to cart button, there's a little box that says add plunger and tip. All you gotta do is check that, and I'll send it to you. All you gotta do. So you gotta make sure, of course, this is a new IC chip. You can't reuse the old one. The old one, all the balls are fucked. You can reball it, yeah, but you know, I've got a whole reel of these fuckers, so I'm gonna use a new one. So you can see backlight dial just snapped into place. Now just waiting on the driver. It's one corner. Nah, nah, that's not really on there yet. Actually, nah, it's close, but I wouldn't really count that as soldered on. Come on, you fucker. Nah. See, now this is probably too much hot air. So I've really got to tone down the air here. That's why the chip is moving all over the place and fucking everything up. So now, trying to... Wow, what a struggle. I'm a professional, guys, trust me. I've been doing this for days. Years. Months. Days. So yeah, now we're really gonna make sure, because like 2 in a row have failed. So there's obviously some shit underneath those, underneath the VGA IC that's got to go. So now I'm gonna really make sure that those pads are flat, without wicking, because I know it's like it's just because I'm on camera that this shit doesn't work. Like I know that I can get away with not wicking these pads, and it's gonna happen. I promise you. So I'm really cleaning it up with alcohol to make sure I can see underneath. And yeah, there's a lot of shit on the sides there. That was a fail. All that shit on the sides has got to go. Or else that's why this chip is not going to sit in place. The same as before, just pick it away. Don't scrape the fucking solder mask. GTFO. Fuck off. There. This shit up top I'm just scraping away just because I can. Alright, so that looks a lot better. Now, hopefully, we can solder around the new backlight IC without it flying off. So flux. I'm going to clean up this cap a bit. Why not? Okay, now we can put the new backlight driver on. So, we'll see. Third time's a charm. What do you guys think? So, like I said, this is a new chip. You can't reuse the old one. It's fucked. Well, the balls are fucked. The chip's probably still fine. I'm going to lower the hot airflow a bit, because I think that was part of the issue, is that just the fact that that shit was blowing all over the place. And just wait for this chip to snap into place. Yep, there's one corner. Oh yeah, perfect. Look at that, beautiful. See, that's perfectly parallel with the diode there. So that's a good solder joint, whatever, soldering. Yeah, there you go. And zoom out, just look. So what you want to do is look for solder balls that are popping out of the underfill. So that's what I'm doing here. I'm just zooming out, making sure everything looks okay. When you have solder balls popping out from around the CPU, that's because as you heat it up and the underfill doesn't expand, but the solder below, like below the chips that are underfilled does. And what happens there is all like that excess solder that's expanding has to go somewhere. So it'll pop out of the underfill and cause bridging or like shorting underneath the CPU. So, when you have like balls flying out of your CPU, that's how you know you use too much heat, and that's how you know like most likely you're fucked. Unless you really want to reball that shit. So yeah, I'm just gonna give it some time to cool here, and in the meantime, I really want to give a shout out to the guys over at iPad Rehab, Mark and Jessa. They are the first ones I think to have figured this out. This is who I got this. It's actually the coil trick from. I really struggled with this for like 4 months ago. I remember I was trying to figure out why the fuck like all my iPhone 6 backlights were you know dim afterwards. I was fucking checking all the filters, checking for partial shorts. I really had no idea what was going on. I was like trying like 6 different backlight ICs of all different revisions off of like the older iPhones and the newer iPhones, trying to figure out what the fuck is going on. And I never really like no one ever suggests it's the coil, because it's like never the coil. I've seen the coil on like 2 devices ever, and so I kind of figured after I had replaced like the diode and the backlight caps and the filters and the driver ICs like 12 different times. Maybe it's the coil, but what I'm gonna measure. I'm gonna end up replacing the coil, and when it's not the coil, Mark and Jessa are gonna rip me a new one. So I never ended up replacing the coil, and I would measure across the coil, like measure the resistance, and then measure about the same. Um, and the funny, the thing is, you can't, like I said earlier, you can't measure the difference in resistance between like 1 milliohm and I don't know, standard multimeter. You definitely need like a special multimeter to do that. And so finally, Mark and Jessa, I think it was Mark, decided to replace the coil on one, and yeah, it worked. And yeah, now we all say it's actually the coil on the iPhone 6, which is kind of crazy. So our theory is that when one of the caps shorts the ground, all that current just kind of like melts one of the inner windings on the coil and causes an internal short, and that's what causes dim backlight or or flickering backlight on the iPhone 6. And so yeah, just making sure here that everything looks good. My driver is aligned well and soldered on. A lot of the times I'll take off that cap to the far left. If you take that off, you can actually see the balls underneath the chip and make sure they're all looking good looking balls. Because who doesn't look like a good looking pair of balls? Wow. Sorry guys, it's really late. It's like fucking 2 in the morning. Okay, so it's been about like 10 minutes or so. So now my board is sufficiently cooled, and so I'm going to go ahead and it's like not burning hot to the touch. That's how sufficiently cool worked, in case anyone was about to ask. So I'm going to go ahead and take my housing and put the board back in and test it out and see if it turns on. Fuck. Fuck if it turns on. See if it That's backlight, sorry. So, let's see. What is in the housing? Connect the screen, and now let's see what happens. Oh, Apple logo. Remember, here's our comparison one. It already looks very much brighter. Move the microscope out of the way. Go away. I'm gonna get in trouble. Look at that. All good. So if I take this, do the same thing over here. And say if I, let's see if the brightness adjusts. So, whoa, down. So yeah, there you go. Full brightness access, no flickering. Looks good as new. So if you ever want your backlight, whatever the fuck these are, drivers, coils, even backlight caps for the iPhone 6, they're all available at MicroSolderingSupply.com. Thanks for watching.